Morning, students. Unfortunately, I won't be able to be with you today. So we're going to have you watch a quick video. The idea with this video is you're going to pause the video when certain screens come up. You're going to work through the problems and then hit play, and you will be able to then see the answers revealed. The goal today is to get you ready for the chapter test, chapter 8 test, which will be on Friday. We'll go through what's going to be on the test in a couple slides later here. The first warm-up here is really to review what we did on Monday with the Desmos activity of graphing rational functions. So what I'd like you to do is pause the video right now and go ahead and describe the effect each number has on the graph of a rational function. And then if you can, create a very rough sketch of this function here and try to do it without a calculator. Pause the video. We will reveal the answer. So let's go over this quick. Just a quick refresher. When we're talking about the general form of a rational function, we have a, h, and k. Remember, h is the one that's opposite of what it appears. So if we ask you to describe the effect, we're looking for what does each number do to the graph specifically, what direction does it move, and by how much. So let's look at the a value. The a value is -2. Because it's a negative, the negative in the a value will cause a reflection over the x-axis, and it will also cause, the 2 will cause a vertical stretch. The 5, notice it says x plus 5, but the general form is x minus 5, so this is opposite of what it reads. The h value is a -5, which will cause a horizontal shift 5 units to the left. Remember, opposite of what the equation reads. And then the k value is -3. This will cause a vertical shift down 3 units. So if we ask you to draw a sketch of that, what you're going to do is you're going to actually take the horizontal movement and the vertical movement and actually apply those because those are the asymptotes. So what I have here is let's take the horizontal asymptote and shift it 5 units to the left. 1, 2, 3, 4, 5. So on my graph, I would draw a dotted line. I could even label that as and that's at the equation x equals -5. So notice your h value is going to give you your vertical asymptote. All right, and then the next one is what about the k value? Well, the k value shifts everything down 3 units. So the original asymptote right here at 0 is going to shift 1, 2, 3. And that is our horizontal asymptote. I'll just abbreviate that. But that equation is at y equals -3. And notice, that's exactly your k value. All right. Now, we said go ahead and graph a rough sketch of this. So all we're looking for here then is, can you apply what the a value tells you to? Well, the negative is going to reflect it over the x-axis. Now, originally, you don't have to write this part. This is where our original hyperbola would be, right? The branches are going to be in the first and third quadrant. But this graph up here is going to actually reflect over the axis. It actually reflects over the axis first, and then it applies the shift, but it's going to go down here. And my pen is not super accurate. So that means I can erase this one because the a value shifted it over. And then on the other side, the one that was originally in this quadrant is going to flip up above here. Try this again. And we're going to graph it like this. Now, if I really, wow, I got to get better with my stylus pen here. That's a rough sketch. Notice, very rough. If I wanted to get more accurate, I could actually plot physical points here using my calculator or just plugging in. What if I plug in -6, -7? I'll get some points over here, and then those points would be mirrored in the other quadrants. So that's a very rough sketch. The big thing is, do you know that the h tells us our vertical asymptotes and the k value tells us our y? and the a value tells us which quadrants we're going to be in and by how much of a stretch we have. So again, this is a very rough sketch, but hopefully you get the idea. Let's try another one. What if I give you a graph? Can you write the equation of the given rational function knowing that the a value is positive 6? So I'll have you pause it, write down your answer. So let's take a look. What do we know? We know that my horizontal asymptote is at the equation y equals 5 because I shifted up 5 units. Now notice, I shifted everything up 5 units. Wait a minute, isn't shifting something up the k value? And then I shifted everything to the left, to the right, 2 units, which is my vertical asymptote at the equation x equals 2. Well, by shifting everything over, that tells me that h is 2. Now, we already know that a is positive 6. The big thing is notice it's positive, so it's in the upper right first quadrant and lower left 3. So that's our indication of positive. If it was in these two quadrants, then we know it would be a negative 6. But we know we got a up top is 6. I know my shift to the right is 2. Now notice when I just plug that in, it's opposite of what it reads. So x minus 2 is what the equation would read, but we would shift to the right 2 units. So that is an accurate sign. And then the k value is shifting everything up 5 units. And there's the equation for this rational function. All right. This is our quote for the day. You shall not pass, because it's an asymptote. Okay, so we have a test on Friday. What is the test? It's 30 points, so it's not as big as the other tests. It's basically the same value as the Chapter 6 test. You're going to have a 90-minute time limit. It will be taken in Schoology. The topics are going to be multiplying, dividing rational functions, which was 8.4 in our textbook, adding, subtracting rational functions, which was 8.5, and then solving rational equations. We had 2 methods for that. That came out of 8.6 in the book. One was cross multiply, the other one was clear denominators. You really get to choose because you could apply cross multiplying. You could add or subtract both sides to get a proportion. So you could always use cross multiply and divide. We'll go over that. The big thing is whichever method you choose, make sure you check your answers for extraneous solutions. And then we have graphing rational functions, which we just reviewed. All of these assignments are on Delta Math, so if you're confused or have any questions on those, remember you can go back and just try more problems from those Delta Math assignments. So what I'd like to do then is we're going to go over how to multiply and divide rational expressions. Go ahead and pause this. I'll reveal the answers in a minute, and then you can check your work. All right, so let's go over the answers here. So first thing, what do? Well, we factor each numerator and denominator, and then I always just cross it out once it's factored. So go ahead and check your factors for each one. And then once everything is in factored form, you can reduce out if there's a common factor on top and on bottom, and x minus 5 over an x minus 5, that'll reduce out to 1. I have an x plus 4 and the x plus 4, that'll reduce out. And then there's nothing else, no other common factors on top and on bottom. So I get x minus 3 over x plus 8 times x minus 5. Leave the denominator unfactored or factored in factored form. There's nothing up top we can simplify, so I'm just going to leave that and we're done. So what do we do with division? Well, first thing, I want to have a fraction divided by a fraction, right? So let's make this into a fraction, put it under or over 1. And then we don't like division. So what I'm going to do then is I'm going to rewrite this problem as a multiplication by the reciprocal. So we flip the second fraction, and then we factor the numerator and denominator. So check the factors of those, and then same game as multiplying. I have an x minus 4 and x minus 4. I have and that's it actually. The only thing that's left over on top is x minus 7. On bottom, I have an x plus 4, x plus 1, and x plus 4 again. Now keep in mind, sometimes kids want to reduce out the x plus 4s because there's 2 of them. But there isn't one in the numerator and one in the denominator. They're both in the denominator. So in that case, we'd have to write them multiplying them together. And actually, a better way to write two items that are exact same by that are multiplied together would be to rewrite it as x plus 4 quantity squared. Either answer here or here would be accepted. All right, you can pause the video, check your answers, and then let's try another one. Add or subtract rational expressions. So we'll pause the video, have you guys work through this one. All right, so what do? Well, our rule with adding or subtracting expressions is we need a common denominator. What I usually do, I don't love subtraction. I'm going to turn this into adding the opposite. And the reason why I do that is so I don't ever misplace this negative here. So change that to adding -6. And now our goal is to get the same denominators. Well, you notice this denominator already has an x plus 4, and so does this one. But we have an extra x minus 3. So this fraction over here needs an x minus 3 brought into the denominator, but the only way we can do that is if we multiply the top and the bottom by x minus 3. So what I'll do now then is we're going to keep the bottom exactly the way it is, and then we'll distribute the top part and simplify. So I'll pause and do all that. So we combined the two numerators, 3x, and then I distributed the -6. And then I left just one denominator because that's the rule. Keep the denominators the same. So now I'm going to combine my like terms here. 3x minus 6x gives me -3 plus 18 all over the LCD x plus 4 times x minus 3. Now before we say we're done, we should just check the top. I noticed that they're both factorable. So I could pull out a factor of 3. And if I do that, I get a -3 actually. You pull out a 3 or a -3. I pulled out a -3 and I get an x minus 6 left over, which isn't a common factor with anything in the denominator, so then I know my answer is that. All right, now we get to the solving portion. Go ahead and try both of these, hit pause, and we'll go over it in just a second. All right, let's look at this first one. So cross multiplying, because we have a proportion, fraction equals a fraction. I put parentheses around anything that is more than a number, just so I don't make any errors. And then my advice is just to set up the cross product. 3 times 2x plus 4, and then x plus 2 times x minus 3. Once that's set up, both expressions are equal. We're going to distribute the 3, and we're going to FOIL. You can check that work here. I didn't show my arrows, but I FOILed. And then combine like terms. The next step is to move everything over to one side. So I'm going to subtract 6x and subtract 12 to get a trinomial expression equal to 0. Now we're at the point where we can factor the trinomial, if possible. Remember, if factoring doesn't work, then the quadratic formula would be our option for solving this. Set each parenthesis equal to 0, and we get 2 answers. Now, we're not done, right? We have to check. And one of the things you can do very quickly is notice if I have x minus 2, and I plug that in right here to the original expression, -2 plus 2 is going to give me 0. I cannot do 3 divided by 0. That results in an error. So therefore, I know that x equals -2 is an extraneous solution. So I'm going to cross that out. Call it extraneous. But that doesn't tell me that 9 does or does not work, so I have to check. So I'm going to take 9. I kind of did some work in my head. 3 over 9 plus 2 is 3/11. And if I do 9 minus 3 over 2 times 9 is 18 plus 4, that simplifies into 6/22, which reduces down, and we get 3/11 equals 3/11, which tells me that this is a true real solution. And we like that. All right, so let's try the next one. All right, I'm going to show the first step here just to help you guys out, and then I'll go through all my steps. But if I notice, the method I'm going to use here is clearing the denominators. Now you could add these two expressions together following our rules for adding, and then you'll get a fraction equals a fraction and solve with cross multiplying. So that's a little bit longer way to do it. The faster way is clearing the denominators. Now, what do I notice? I notice that I have an x plus 6 and an x plus 6. But then I have an extra x here. So my LCD is the x plus 6 times the x. And what we do then is we multiply each expression by the LCD. So I'm going to multiply by x plus 6 times x for the top here, as well as here, as well as here. Now, that's the key step, because the next thing is what's going to happen is we're going to reduce the denominator. So I have an x plus 6 that reduces out. Here, I have an x that reduces out. And for this fraction, I've got an x plus 6 that reduces out. And what's left over is the expression 1 times x. So I have 1x plus. Now you could FOIL here, or you could just write what's left over. X plus 1 times x plus 6. And then I've got 13 times x. So I'll pause it and work through the rest of this. You guys can simplify. All right, so once we cleared the denominators, we have to FOIL. When you FOIL, you end up with this expression. Combine your like terms, and then move the 13x over to the other side. And we have another trinomial equal to 0, which is factorable. So we got -2 and -3. Set each one equal to 0, and we get 2 answers. But just like the other one, we're not confident in those answers until we check them into the original expression. So if I plug in, let's check 2. If I plug in 2 into the original expression, and we end up doing some simplifying, I got all the denominators to be 8. I end up with 13/8 equals 13/8. So I get a true expression, which means x equals 2 works. And then the same thing with 3. Go ahead and check 3. Get a common denominator of 9 to add the left side together. And then we end up with 13/9 equals 13/9, which gives me 2 real solutions. So both answers are accurate. So in this case, I would have no extraneous solutions and 2 real solutions. All right, so your homework tonight is the review assignment in Delta Math. You get 1 problem from each category. If you need to work on a specific category, please make sure you do more than just the 1 assignment or 1 problem that is assigned. You can always do more than that. And then the Chapter 8 test is in Schoology. It will be due at 2:30 on Friday. So please make sure you take that. And next week, we're going to be dealing with Desmos. So please make sure you bring your laptop on Monday next week, and we'll introduce the project. All right, have a great one. Work on any missing work and get that turned into Schoology. Adios. Have a good day.